We've talked about reliability and validity of measurement instruments like surveys and blood pressure readings and things, but we also want to look at critique of the validity of an entire study. We want to make sure that we're only using the top quality research, the best available evidence we can when we're trying to decide how we should change our practice. So these slides we're going to go over are going to tell us about how to look at the whole study, not just an instrument like a survey or questionnaire. So really, your book goes over 4 different types of validity. That is the whole study. So we're going to go through each one of these in general, and I'm going to give you kind of some examples, and then we'll look at some final key takeaways about clinical significance and that kind of stuff. So first of all is statistical conclusion validity. That's a mouthful, but basically it refers to how well can we trust the statistical outcomes that occurred in our study. So if we believe that our hypothesis that we made was probably not true and that our intervention really did not help our outcome of interest, then we might be upset because we feel like, well, we did all this work, we planned this intervention, and then it didn't even create the outcome we thought it would happen. Sometimes that happens. However, that might not actually be true. There are errors that sometimes happen, and the reason it happens is because we did not have enough people in our study. Our sample size was too small. So with statistical conclusion validity, we can't be 100% sure that our intervention really didn't work. The only way we can try to prevent statistical conclusion validity issues is by having a big enough sample, okay? So that means that we need to make sure that we have enough people in our study to power the study. So when you hear the word power, think of sample size, and the whole purpose is that we're trying to make sure that the outcomes from our statistical analysis are indeed correct. We could go into way more depth than that, but that's enough. Internal validity has to do with, did our independent variable cause changes in the dependent variable, or was it something else outside of my study? Okay, so there are different types of threats and biases that can creep in that can cause changes in my outcome of interest. Okay, if I do a weight loss intervention, and my outcome is weight changes, then I'm hopeful that my intervention really made the changes in the weight. But of course, there are other factors that can influence an individual's weight, and those things are called confounding or extraneous variables. So in order for me to have good internal validity, I've got to make sure that the intervention caused changes in the outcome and not something else. I'm not going to go over all of the different biases and threats on this slide. However, I will go over a couple of them. First of all, with selection threat, that means that I did not use random sampling, okay, or random assignment. If I don't use random sampling, then that means that I've handpicked, in a way, the people who were going to be in my study. So I have either used convenience sampling or consecutive sampling, some form where I have not taken it out of my own hands. For true random sampling, each individual has an equal chance of either being in or being out of the study. It's simply left up to chance. If I have any part in that, then it could be selection bias, which means that my sample is not going to look like the population of interest that I'm hoping to study. Okay. Another one that we'll look at is this attrition threat or attrition bias. Basically, this is very common, especially in a longitudinal study. A longitudinal study is a study that collects data over multiple time points, not just one time. So if we want to follow a group of participants for, say, 5 years, the odds of everybody that started the study still being a member of the study in 5 years is slim because people drop out. After time, you just kind of get over it. You don't want to be in the study anymore. I don't want to have to go get my blood drawn every year. So I've decided I just don't want to do it anymore. So the problem is the people who drop out of the study look different based on the people who've dropped out. let's backtrack. The people at the end of the study who finish it look different than the people who started the study. And so those people who dropped out for a reason probably, whether it's bored or they moved or their financial issues. So we have a different sample at the end than what we started from, and that can certainly bring bias into our study. External validity has to do with generalizability. Basically what that means is which type of people can I take these findings and generalize them to. So for example, if I studied only Caucasian men, then I can't take the results of my study and think that they're going to apply to women or to Asian women or to even Asian men, because this is not the sample that I studied. So I have to be careful. If we look at studies that have a wide variety of participants in it, then we are more likely to be able to generalize the outcomes of that study to bigger groups of people. One way that we can increase our external validity is through replication. That means we're actually kind of repeating a study in a different population, in a different setting, to widen the types of people whom we've studied. And when we do that, then we can generalize to a bigger group of people. In fact, some studies are actually multinational studies. I've seen examples of studies who have studied samples in the United States, United Kingdom, New Zealand, Australia, South Africa, all at the same time. And because they've done that, we've got different continents, we've got different types of demographics, and the outcomes of those studies are more generalizable and fit a bigger group of people than if we would have just studied one small piece of one small hospital, say. Okay, the last type of overall study validity is construct validity. Now, don't get this confused with the construct validity of a single instrument. This is different. This is looking at the full bird's eye view of the study. So basically, if I'm wanting to do a weight loss intervention to help my participants lose weight, then is my intervention good? Is it really going to promote weight loss, or is it just some exercises I threw together at the last moment? Okay. Do my variables actually measure what they're supposed to be measuring? That's that piece of construct validity we looked at before. Okay, so we need to think about all these things when we're critiquing a study. So some other questions you can ask yourself. For internal validity, did independent cause changes to dependent? Are there other possible confounding variables that could explain the results that came about in this study? You should ask yourself that when you're reading it. Sometimes an outsider can easily see holes in a study that the researchers might not have seen. If we're trying to talk about weight loss as an outcome, there are other things beside an intervention that can cause weight loss. People could be out on their own doing extra exercises outside of time, or they might be taking weight loss supplements or pills, or maybe they're changed their diet and they've decreased their caloric intake. So we've got to know about those things. Those are confounding extraneous variables. For statistical conclusion validity, one thing we can check, especially it should be in the methods section of a study, is whether the researchers did a power analysis. What that means is it's a statistical test. I'm not going to go into the details of what all it does, but it gives us a number, a minimum number that we should have as our sample in order for us to have adequate power to trust our statistical outcomes. So an example, if I'm doing an experiment and I run a power analysis, which is just a calculation, and it tells me I need 240 people in my study, then I've got to make sure that I have at least 240 people in my study so that I can trust the statistical conclusions drawn from my study. And then lastly, you should ask yourself as you're reading studies, which type of people can I take these results and transfer or generalize them to? Okay, it needs to be similar to the people who were actually studied, as I mentioned before. Okay, ultimately, we want to make inferences for this study. So remember, when we are doing a study, say a quantitative study, we are studying a sample. That's a smaller group of people who make up a piece of the overall population that we're really interested in. So there's no feasible way I could go out and study and collect data on every type 2 diabetic in the world. I can't. I mean, it's just impossible. I can't even find all the type 2 diabetics in the United States or even Louisiana for that matter and get them into my study. But if I'm doing a study about type 2 diabetics, I want to not just learn about those 200 people in my study. I want to learn about every type 2 diabetic. So I've got to make sure that that sample of 200 people is diverse enough and looks like the full population of type 2 diabetics so that I can make inferences about the whole population. So this is an example of that. These are my study results for my supposed 200 type 2 diabetic participants. I don't want to just learn about those 200 people. I want to make inferences based on those 200 people of what any type 2 diabetic would act like or be like in that same situation. Okay, so it's super important that the sample looks like the population. Otherwise, we can't feasibly make these inferences. Okay, and then just a final word of wisdom. When you read a study, we cannot always take it at face value. We have to read with a discerning, skeptical eye. When you're reading, we're not trying to pick holes in everybody's work. There are strengths and there are weaknesses to every research study. So as we read them, we need to be focused on what are the strengths of this study? What makes this study really strong and usable for my evidence-based practice purposes in my own workplace? But at the same time, what are the biases and the weaknesses and the errors in this study that could poke holes in the outcomes and that could limit this study's usefulness in making evidence-based practice decisions? You can only use what the researchers told you in the article. Okay, you can't assume things because we can't be sure that that's true. Okay, so when you're reading, look for strengths, look for weaknesses, and ask yourself some of the questions I told you in this study and this video so that you can critique the overall validity and believability of the research studies that you're looking at.